right, guys, here we go. You ready? All right, guys. Okay, so today is Wednesday. We have a quiz on the differentiation rules on Friday. That didn't pick up. It's a really bad mic, so it didn't pick up. There was a curse word said. I'm not going to say it, but it was a bad one. Okay, so anyway, and you know you have that take home that's due on Monday? Okay. So we're going to continue with L'Hopital's today. We're going to find limits of other indeterminate forms. You know, 0 over 0, infinity over infinity, they're not the only indeterminate forms out there. Nope, this is new. See how I'm like weaving in the old and the new? Beautiful quilts. Yeah. Woo! Oh, I have to check the homework. Fill in the do now. Shoot, I don't want anything inappropriate. But at least the sound quality is so bad that you can't really tell. Oh. I got single digits. That's the derivative of e to the u is e to the u. I am my own grandpa. That's why I play that, just so you remember. Just to make that clear. You watched it. But it makes sense. Okay, so let's go over what we know so far. L'Hopital's rule may be applied when the limit of both numerator and denominator is either 0 or if they're both infinity. And it doesn't matter the plus or minus. If you wind up with a positive infinity over negative infinity, you still have to do L'Hopital's. Whatever. Okay, whenever that happens, you get one of those two indeterminate forms, then what is this limit as x approaches the limit still? You still got to take the limit. Like, you're not out of that part, but f prime of x over g prime of x. Okay, let's check out this homework. Let's see how that went. Number... Wait, no, I didn't give you the answers today. Sorry, you have to look. Some days when I think it's going to take too much time, I'll do that. So number 1, you should have 5. You did have to apply L'Hopital's, but just once. Very civilized. Oh, yeah, 3 is negative 5 over 2. This one you had to apply it over and over and over again. You got 5 over 3? Does anyone else? Oh, you have negative? That's weird, you'd have the reciprocal. Something... Alright, we have to talk about number 2. Did you apply, like, when you tried to plug in the negative 3, you get 0 is 0, so you can apply L'Hopital's. Oh, let's just do this right here. This is an easy one to do. So you take the derivative of the numerator, 1, right? So you have the limit as x approaches negative 3. So that's just 1 over. Now, when you take the derivative of the square root of u, do you remember what you get without saying negative exponents? It's 1/2 u to the negative 1/2 times u prime. So it would be u prime over 2 rad u. Good. So when I take the derivative of the square root of x squared minus 5, I'm going to get u prime, the derivative of the inside, 2x over 2 rad u, where u is the x squared. I mean, just saves time when you know the pattern. So the derivative of the square root of u is u prime over 2 rad u. And now, I can cancel the 2's, and I can just flip it. You have 1 over a fraction. And that's why you wind up with, you have 1 over the radical top. So that was a little fun with the radical. Number 3, you had to apply L'Hopital's once, still indeterminate twice, and then you get the negative 5 there. No? No good? Oh. 4 Oh, that too. I'm showing that stuff. Oh, I have it nicer here. See, this is the thing you have to know for number two. You have to be able to just know that derivative of square root of u is put prime over 2 squared u. Make a note of that. So I wrote this yesterday and I already forgot. Okay. Number four. Yeah, if you didn't just compare degrees, if you actually wanted to practice using L'Hopital's, look how ugly this thing got. Oh, what? Oh, wait, we can't compare degrees. This is x approaches 5. Never mind, you had to keep going. Yep, there's no way. The answer is does not exist. Well, wait a minute. That means, yeah, but at this point, okay, you just went one, you applied L'Hopital's one time too many. Because when you got to this, you did it again. You said 72 over, and that's why you got the 3. But you can't apply L'Hopital's again. Because at this point, 5 times 72. What is 5 times 72? Let's think about that. I have it wrong here? Oh, 46. Oh. Oh, so it's, okay, 360 minus 246. So that's my number's off. It should be 124. Wait, what is this? Seriously? 114. I was off. Sorry. Okay. Okay. But the point is, guys, when you get to this point, you plug in the 5, but you don't get 0 over 0. You get some number that's not 0 over 0. You get 114 over 0. And when that happens, there's a vertical asymptote. Now, technically, when you have a vertical asymptote, you got to see if maybe on both sides it's going up to positive infinity, or both sides negative infinity, or one of each. So at that point, I got here, I got to check out the one-sided limits. You know either side is going to positive or negative infinity when you have a vertical asymptote. You just got to determine the sign. So if you approach 5 from the left, that numerator, that 114, that's positive. But from the left, this 24x minus 120, you take a number a little less than 5, it's going to be negative. So you can have a positive over negative, but it's going to go to negative infinity. So if I were to graph this whole thing, I know there's a vertical asymptote at 5. And I know as the x values approach 5 from the left, the y's are heading toward negative infinity. Now I look at the other side. Vertical asymptotes, you want to look at each side to see, check out the signs. I have that one. So as x approaches 5 from the right, the numerator is still heading toward this positive value. The denominator is still heading towards 0. But this time, it's going to be positive. You see that? 24 times the number a little greater than 5 minus 120. So positive over positive is positive, so that's positive infinity. We have a vertical asymptote at 5, and one side is going to negative infinity, the other side positive infinity. So the limit, after all that, does not exist. And when you do all that, if you get a constant over 0, you might say positive infinity, you might say negative infinity. Or, yeah, that was a little difficult. Oh, good one. I think that was the toughest one. 5. 5 was 0 over 0. You apply L'Hopital's, you get 0. Did you get that? You got 3 over 0? What's the ln of 1? 0. 0 minus 1 plus 1. So the numerator is 0. No? Wait, why are you guys getting 0 over 3? Are you doing 4x minus x instead of x to the 4th minus x? Oh. Oh, this time you get 0 over 3. Okay, I thought you got 0 over 3 originally. Okay. Yeah, you got 0 over 0. You apply L'Hopital's. Now you get 0 over 3, and that's 0. Yeah. Okay, but you're right. The derivative of e to the negative x is negative e to the negative x, but it's a minus in front. So it's minus negative e to the negative x. So it's positive e to the negative x. So that one you get 2 for first step. You did have to apply L'Hopital's. You had a 0 over 0. Yep. Number 7. The answer is 0. Get that one? Yeah. Okay. That's looking good. Question's that one. 8. Oh, you had to remember the a to the u rule. No? Answer. Well, did you realize at first you had 0 over 0? So you applied it. Did you get the right derivative? Oh, that's the u prime. Remember, it's a to the u, ln of a times u prime. Here, okay, you plug the 0 in. So if you got the right derivative, remember the derivative of a to the u is a to the u times the ln of a times u prime. They just have a different order here. Well, when you plug in 0 now, you try to get the limit, you have 2 times the ln of 4 plus 0. 1. So you have 2 ln of 4 plus the cosine of 0 plus 1. So you have 2 ln of 4 plus 1. Down here we have the secant of 0. We got to square that. What's the secant of 0? The reciprocal of the cosine of 0 is 1. So that's just 1 squared plus the cosine of 0, also 1. And that's where that 2 comes from. Oh, so where's the problem? Yeah. Oh. So yeah, the answer is 2 ln of 4 plus 1 over 2. This one? Actually, I don't think so. You're going to have like a test like a L'Hopital's or if it's like next week. Yeah. Yeah. No, anything I give you would be simple. How would you use the graph? Yes. All right, 9 is 2/3. Are there any questions, number 9? Now, this is one you could have just compared degrees instead of going through L'Hopital's. Yeah, that was one because x was approaching infinity. Okay. Number 10. So you try and you have infinity over infinity. You see that? Okay, so you apply L'Hopital's. You have the 8x minus 5, that's for the numerator. Down here, you have e to the 5x times 5, or 5 e to the 5x. The derivative of ln of x is 1 over x. You have 1 over x. You try again, right? So, as x approaches infinity, the numerator, 8 times infinity minus 5, that's heading toward infinity. And then the denominator, it's like infinity plus 0, that's still heading toward infinity. So we have to do it again. We have to apply L'Hopital's again. So the derivative of the numerator now is just 8. Down here, you had the 5, then the derivative of e to the 5x is e to the 5x times 5. Now you have 25 e to the 5x. And the derivative of 1 over x is negative 1 over x squared. Negative x to negative 2. Then you try it again. So it's not just taking the derivative, you still have to find the limit. Now, as x approaches infinity, the numerator stays put at 8. So the denominator's blowing up to infinity. Yep. This point? Yeah. Well, no, we don't take the derivative. We don't apply L'Hopital's again. Because right now, when we take the limit, it's not going to be an indeterminate form. So now, like, we're going to be done. So we have 8 over infinity. And if you think about fractions, where the denominator is just growing and growing and growing, and the numerator stays put, that fraction equals 0. The 0 is the answer for 10. What's the, like, I know that there's confusion. I'm just not, yeah. This one you can't compare degrees because, yeah, it's not polynomial down there. Yep. Why that whole thing 0? Oh, that's good. That's a good question. So we have the numerator is 8. Now the denominator is not staying fixed. It's changing, right? It's just growing. So let's say we start out at 10. I could have picked any number. Let's make it a little larger. So think about 8 tenths. Now we got 8 100. It's getting smaller, right? Now we have 8 1,000. But we're going to keep going, right? And we just keep going forever and ever and ever. If I go just keep going, I can get as close to 0 as I want. What x is approaching infinity? Like depends what you have. But I think I'm going to answer your question in a second. Anytime you have a constant over either plus or minus infinity, it's always going to be 0. Yeah. But yeah. 11 was just mean. I forgot to warn you about that. But did you just get it because you saw it was there? It's x over x, so you can do that. But if you tried to get into L'Hopital, it starts messier and messier and messier. Okay. But, okay, if you did that, that's fine. If you rewrote it, and now the reason you can say that the square root of x squared is just x, how do we know it's not negative x? Square root of negative 8 squared does not equal negative 8. Yeah. The reason you know that the square root of x squared is just x is because you know x is positive. So the square root of x squared is only equal to x if x is a positive number. So if I take the square root of positive 8 squared, yeah, that's going to be positive 8. But it's only true for positives. But you know x is positive because x is approaching positive infinity. So if you realize that first, then yeah, it was an easy problem. Then you could apply L'Hopital. But if you try to apply L'Hopital's as is, you have infinity over infinity. You just start getting to all the radicals. Did anybody try that? Okay. Just like to. So I have to go back. Nope, you don't see that? Oh, well then you have square root of x over x. Look, I'm sorry, you have x minus 1 over x. As x approaches infinity, that's still infinity over infinity. There's 2 ways to handle this. Either you just compare degrees, because x is approaching infinity, or apply L'Hopital, derivative at the top, derivative at the bottom, limit of 1 over 1 equals 1. Okay. Yeah, that was a little mean. Okay, numbers. This is real numbers. Okay, good. This is like one little snapshot of real numbers that looks back to the abstract again. I want you guys to write the product 3 times 4. That's the best way I can represent them. I want you to write the product 3 times 4 as a quotient. When we have a product quotient, skipping over something else, using either factor, using either the 3 or the 4, and the reciprocal of the other. Think about it. Okay. Yes. Right now it's a product. I want you to write it as something over something else. I want you to write it as a quotient. Mm-hmm. Yeah. You got it? Here I'm going? Alright, Rohit, you're going to help me out here. So 3 times 4 is equal to, well, I know, but 4 divided by 1/3. Now, is that true? Yeah. Anyone get a different answer? Yes? Yeah. Okay. Whenever you divide, you guys know when you divide by a fraction, it's the same as multiplying by the reciprocal. Right? We're just thinking going the other way. You have a product, you can just think, and as long you could write it as a quotient, just keep either one of the factors and divide by the reciprocal. When you divide by the reciprocal of the other, you're going to get the same way of thinking about it. All right, where is this going? Okay, because I promise you there are other indeterminate forms, things that we don't know what they are, right? And one of those, another indeterminate form is infinity times zero, or zero times infinity. What's that? Is it zero? Is it infinity? Who wins? Yeah, well, they weren't thinking infinities back then. Whenever you have an indeterminate form, like when you try to figure out the limit, you get um, 0 times infinity. Either what you're going to do is you're still going to take the limit, but instead of leaving it looking like a product, you're going to write it as a quotient. And your hope is to get 0 over 0 or infinity over infinity. So holy cow. Okay. That's actually interesting. Well, let's first of all see what would happen if x is approaching infinity. What's the first factor heading toward? X squared. Infinity times e to the negative 3 times infinity. So that's like, that's a 0. Oh, we don't know what infinity times 0 equals. No! Infinity. Well, if I said e to the negative 100th, how would you figure that out? How do you deal with negative exponents? No. No. But how would you rewrite that without a negative exponent? Okay. Over like 1 over e to the infinity. Really? Oh, okay. But we all agree that this, right now, infinity times 0, and Angelo has to agree with us, does not have to equal 0. It could be infinity. It could equal 7.2. I don't know. All right? This is something that's indeterminate form. Just like 0 over 0, we get only 3 answers. Infinity over infinity. Oh, shoot. You're going to be right. They mixed up for yesterday. But only in this case. Infinity times 0 could be anything. All right. So now here's the thing. We want to be able to use LHopitals. We've got to make this look like a quotient. So we're going to leave the limit as x approaches infinity. I want to keep one of the factors as is and divide by the reciprocal of the other. What are you going to say, Melanie? Because you're going to skip the x squared. Huh? I think that was very good. If you cut the x squared, it doesn't matter. Sometimes one works out so much easier than the other. Now, right now, I just don't like the way that looks down there. Can we rewrite that denominator? Yes. Correct, right? It's 1 over e to the negative 3x, just e to the 3x. So before we even try to take the limit, let's just rewrite it. Make it look perfect. So now we started out with a product. Now we've got a quotient. Now the question is, what is this limit? Well, let's look at the numerator. As x approaches infinity, what's the numerator heading toward? Infinity. And what about the denominator? E to the infinity? E to the infinity, e to the 3 times infinity, think of it, e to the x graph, going up to infinity. So now it's in the indeterminate form infinity over infinity. Now we have something to do. We can use LHopitals. Like this. Okay, so it's infinity over infinity. So we write this limit equals the limit as x approaches infinity. What should I write for the numerator? 2x. What should I write in the denominator? Right, even the 3x times 3. Is it still indeterminate? Is it still infinity over infinity? So we still have infinity over infinity. We have to apply LHopitals again. All right, we got time. times 0 is always going to be a 0. Because it's the 3's here, and then when you take the multiplier, derivative of e to the 3x is e to the 3x times 3. So you have 3 times e to the 3x times 3, or 9 e to the 3x. Bam. So yes, now we are going to get 2 over 3. That's 0. You don't have to write this. You just say 0. Now, yep. Okay, let's try another one. Yep. Good idea. Oh, I like this one. I like this one. Let's first see what indeterminate form we have. So we're taking the limit of a product. The first factor, x squared, that's heading off to infinity. Now, as x, we got to work, this next one's a little more complicated. Let's look at the inside, the argument here. As x approaches, well, it's going over infinity, but it's going to approach 1. This is what we call the argument of the ln. What's the size of x approaches 1? Why? How do we know x minus 1 over x plus 1? How do you guys get that? Okay, they're both approaching positive infinity, so you could do a little mini LHopitals in your head. Right? If you have infinity over infinity, the derivative would be 1 over 1. Or just compare degrees when x is approaching infinity. What did I say? Ratio leading coefficient. No, positive 1. But the second, and the ln of 1 is approaching 0. So infinity times 0, what is it? I knew you were going to say 0. I was waiting. I really hope this one's not 0, because it's going to be really bad if it is. I know. Bad. Okay, so when I get infinity times 0, I have to rewrite this as a quotient. Hopefully. Now, which one do you want to keep and which one you want to flip? Keep the ln. I'm so glad you said that, or it gets really ugly. I always keep the ln. Keep that one. So then what do I have to write in the denominator? So, what's that? Well, if I bring it up, we're just going to kind of be back where we started. So I want to keep it looking like a quotient. I'm going to leave it for now. Let's see what this is now. So what about the numerator? We have what is the whole numerator equation? So the ln of 1, which is 0, over 1 over x squared as x approaches infinity, that's approaching 0. So now, it's still indeterminate, but we can use LHopitals. Okay, so this limit is equal to the limit as x approaches infinity. Let's start with the derivative of the numerator. We have to do u prime over u, and the u is a fraction. Boy, we have lots of room on this one. Oh my gosh. We're just going to start with the derivative of the ln. So it's u prime over u, where u is x minus 1 over x plus 1. I don't know why I did that. It's not bad, right? You're going to see. So that's my u. Now I need u prime. What's the derivative? Use the quotient rule. Let's start loading high. Low. X plus 1. The high is 1. High. E low, which is 1. Oh, I didn't leave myself room for the over x squared. It's alright, I can do this. I know, so you should have thought about that. Loading all over the denominator squared. Whoa. So right now, I've just taken the derivative of the numerator. But this is going to clean up beautifully. Yeah. Should I take the derivative of the denominator or just clean up this part first? I can do it? It's all over the derivative of... So it's negative 2x to the... Well, we still have to clean that up, but I want to know what's the derivative of 1 over x squared. Is it just 2? Let me see. Well, that's x to the negative 2. 1 over x squared is the same as x to the negative 2. So the derivative is negative 2x to the negative 3. It's negative 2 over x cubed. The derivative of 1 over x squared is the derivative of x to the negative 2. So you get negative 2x to the negative 3. That. Can I get what? This is the derivative of 1 over x squared. Because first, to take the derivative of 1 over x squared, think of it as being x to the negative 2. And use your power rule. So the derivative is negative 2x to the negative 3, which is that. Now, don't even try to find the limit until you clean this up a lot, okay? There's so much algebra that needs to be done right now. Does anyone see anything? Can you change flip first? Yeah. So this, we have a fraction divided by a fraction. So what we're going to do up here, forget about dividing by this. We'll multiply by x plus 1 over x minus 1. Ooh, and one of the x plus 1 can't. Oh, sorry. Yeah? So I'll cut this out. Well, this, if you look up here, you have x plus 1 minus x minus 1. You have 2x. No, you don't. You have x plus... Oh, the x's are gone. Sorry, you're just 2. So because you have a 1 minus a negative 1, so you just have 2. So really, what we have up here, we're almost there. It looks horrible, but it's not bad. So we have 2 over x minus 1 over negative 2 x cubed. Oh, I forgot my x plus 1, right? That was still here? This one is here. X plus 1 minus x plus 1. You distribute. Yep, I have to have this x plus 1 down here. One of them's still there. I forgot when I was, we still had an x plus 1 down here. Yeah. Well, what's that? Which one? Yeah, this down here, instead of divided by a fraction, I multiply by the reciprocal. Oh, this? Well, if you distribute, this is just x plus 1. And then if you subtract an x minus 1, you're going to have 2. Yeah, I'm sorry, you're going to have 0x plus 2. You'll have just 2. If you clean this up, this is just equal to 2. Alright? So that's why we get this. Now, now we can, if I clean this up some more, the limit as x approaches infinity. You change flip, the 2's will be gone. Let's see, what are we going to be left with? If we just write it. A negative x minus 1, x plus 1. I'm just going to write x squared minus 1. Just multiplying them out. Maybe it'll be easier. Yeah. Okay. Now, this is looking good. You could just compare the degrees at this point, but you could use LHopitals. It is infinity over infinity. Now, yeah, we could just do it again. If we want to stick with the LHopitals, you want to just compare degrees? Okay. So as x approaches infinity, if the degree up top is greater than the degree down here, what are your only choices? Infinity or negative infinity? How do we tell which one? Yeah, you look at the sign of the leading term. And this would be negative, and that would be positive. So if you didn't feel like doing LHopitals a few times, you could get negative infinity that way. Now, it's a good thing I decided decided not to do that other thing today. It was like perfect timing. So you got like a few problems. It's 12 to 16. Six? Oh, okay. Six problems. The homework is the same worksheet you did last night, only you're doing like 12 to 16. It's on the front there right now. Or 12. Yeah, 12 something.